It's not rocket science. Does that mean it's rocket science? I'm not too sure, but what we're going to do is have a look at motion graphs in displacement, velocity, and acceleration. Rocket physics. Featuring displacement graphs, velocity graphs, and acceleration graphs. It all started with a humble pink rocket, accompanied by his trusty orange friend. They were sitting on a lovely grassy knoll, accompanied by an enormous ruler that had 10 gradations on it. Each of those gradations were 10 metres, making it 10 times 10, 100 metres. Now that's definitely not to scale. That guy's way too big for that. He's almost 10 metres tall. And here we've got 3 fantastic looking time graphs. Okay, let's take a look at that first graph now. That's the displacement graph, and as the base of the rocket goes up, we'll track the displacement as it goes up. The velocity graph, now that's the change in the displacement per time. So we're going to work out the change in the actual displacement in each increment to work out what the velocity is. And then following that, we work out the acceleration, which is the instantaneous change in velocity per time. So we're actually going to look at how the velocity changes in each time increment to then work out the acceleration. Now this is just an approximation, so it's not perfect, it's an approximation. Okay, now let's just head into the launch. I'm pretty excited, and this rocket is about to go. Okay, let's have a look at a slow-mo recap. Okay, so when we've got the lift off, everything is at 0, and we're going to assume that the next step there is 0 as well. So the change in displacement is 0, so we've got no velocity and therefore no acceleration. Okay, now we go up to 2. Now its change in displacement is 2, so therefore the velocity is 2. And then we go to 4 and so on. We can see the acceleration creep up because the change in velocity is going from 2 to 4 to 6 and so on. So the acceleration is actually 2 meters per second squared. Okay, now here we go from 12 to 21, so we've got 9 meters per second, and that's gone from 6 to 9, so that's 3 meters per second squared. We're kind of getting higher and higher velocity, so we're going faster and faster, and the displacement's rapidly climbing from 34 to 50. Okay, now this is kind of the peak of the acceleration. Okay, so the velocity actually is still going up, but it changes at a lesser rate, so the acceleration is actually going down. And here near the top, the velocity actually goes down, so the acceleration is negative. And that's because with this particular rocket, we've dropped off the burners there, and you can see the displacement graph curve around like that. Okay, and that's a bit of a physics explanation for this particular graph. So in summary, the velocity is actually the slope of the displacement graph, and the acceleration is the slope of the velocity graph. So as you can see, the displacement is quite flat at the start, so velocity is low, gets steep right in that late middle period, and then it tapers off. So that says the velocity gets its peak, and then it comes back down. Now, with the acceleration, that's the slope of the velocity graph. As you can see, the slope of the velocity graph is kind of high at the start, and it gets even steeper for a little bit, and then it peaks and then goes down. So the slope of the velocity graph goes from positive to negative, and you can see that there with the acceleration. Another way of thinking of it is actually the other way around, is the area under the velocity graph will give you the displacement, and the area under the acceleration graph will give you the velocity. And this is actually related to calculus a fair bit, and the idea of understanding calculus is actually quite important to physics, even though in most physics courses they tend to leave out the calculus bit there. But some interesting stuff nonetheless.
To infinity and beyond!
Cool, thanks for watching this video. I had a bit of fun making this one. Something a little bit different. And make sure you subscribe to this if you enjoyed this video and any others. Definitely write some comments below, especially if you liked it. I tried a little bit different here with this particular movie, so hope you enjoyed it.